Hi, everybody. I'm Aubrey. I'm going to get my clicker skills down. I think it's always nice to show the environment in which a person works. There's my desk. I've been writing software for about 20 years, I'm embarrassed to admit. I started out at a company called the Barbarian Group in New York. We did a lot of digital advertising. Went from there to Apple. We did a lot of digital advertising. I went from there to a company called Particle, which we ended up selling back to Apple, and we did a lot of digital advertising. You may be sensing a theme. So in the new world, I wanted to change what I was going to do, and I wanted to switch to hardware. So I'm making this device, which is called Runcible. I think I brought one. Oh, yeah, I did. So Runcible is modeled on the pocket watch. It's designed to emulate a form factor of devices that humans have had a longer relationship with than the big rectangle that we all carry around now. It's a fairly new idea that we'll haul around a big, heavy rectangle. Before that, humans carried around devices like this. In really, really old times, the sort of magical stone in your hand, which is just calming to hold, contemplative. Later on, the compass kind of helped you find your way. The pocket watch, a little bit more technology integrated in there. The compact mirror, and kind of get a theme. So we wanted a form factor that was fundamentally calming to hold and would change your mind about digital content just by holding the device. You're probably too far away to see it, but I'll show you some pictures. I tend to think of this era as the post-smartphone era. If you saw the talk just now, it's pretty clear that smartphones are in the world and are ubiquitous and are not necessarily going away. But still, if you're an innovative person, if you're a creative person, I think it begs the question, what do we do next? What else happens? And in the post-smartphone era, the main thing that I've noticed is the beeping, this kind of incessant flow of notifications, and these platforms that a couple of big companies have developed, which are kind of becoming conduits for interruption. They encourage different software companies to build value on their platform by bothering you, essentially. And some of those properties have intrinsic value of their own, but even those, I think, are falling prey to the kind of like, well, let's just find other ways to notify people more and beep more, and that's how we'll kind of get out front, and that's how we'll differentiate our line from our WhatsApp, et cetera. Runcible is designed to do something totally different. So there's no notifications. It never beeps. It never rings. It is digitally connected like a smartphone. It has a full stack with LTE data, with Wi-Fi, Bluetooth, NFC even. It is, for all intents and purposes, in terms of brains, a smartphone. But in terms of functionality, it really couldn't be more different. It's quiet, and it's based entirely on a pull model. So just like a traditional timepiece, you look at it when you want to know what time it is. Your watch, if you have a traditional watch, never lights up, and that's on purpose as a feature, I think. You can pull data toward you, your digital life. It will help filter some of that content and make it glanceable. But the big difference is that it's there when you want it and when you're ready. And if you sit on the at the dinner table with your friends, you can put it on the table, and it's an object that can be part of a social experience rather than pulling you out of a social experience. We've also made Runcible very intentionally to be kind of open. It's largely open source hardware to the greatest extent that our vendors will let us be, which I'll talk about a little bit more. And it's designed to be embeddable and to play well in various contexts. I think a big hurdle for getting what people talk about as the IoT, the Internet of Things, if we're really going to make that happen, we have to enable people who are not technology people to bring intelligence and functionality and connectivity to whatever it is that they do. So I always harp on this example. Say you make fixie bicycles. We have a lot of that in San Francisco. If you make a fixie bicycle, you're essentially a craftsperson, and you understand the mechanics of the bicycle, you understand the industrial design, you understand how to source the frames, all that stuff. But how do you join the Internet of Things with just that knowledge base? Right now, the recommendation seems to be either to do some sort of a deal with one of the big companies out there, or to totally start from scratch and go buy like a Raspberry Pi and figure out how to program and figure out how to power the thing and hope for the best. So Runcible is a third way in which we can just provide you with the brain, with a means to write software and utilize the connectivity on the device. And then we provide mounting screws into the frame so that you can do what you want with the object itself. So maybe it's hang gliders, whatever. So the other thing that was really important to me is that I didn't want to preside over the creation of a whole ton of essentially e-waste to be. I've had friends who've gone into the mobile industry and are literally just responsible for tonnage of non-recyclable conflict minerals. I mean, just all manner of horrible things that most smartphones contain. I wanted to see if we could do something different. And I also wanted to see if we could get out of the kind of quick loop cycle that we're in with smartphones, where you're typically throw them away within a year and a half. This is a really new idea for humans. A lot of times our tools last, say, 5 years, say 50 years. So how can we approach essentially a smartphone challenge, but do it sustainably and build it to last? I think the James Gosling, who's this guy who invented the Java programming language, if you've heard of it, he has a great quote where he says, there's two ways to make money in technology. One is bundling, and one is unbundling. He's kind of a wry guy, and if you're a technology person, that joke might mean something more to you. But I think we're at the start of what I think of as a great unbundling. Right now, we're all carrying smart devices which are centralizing fundamentally. But at the same time, if you read large companies' projections, devices are going to get smart by the hundreds of thousands. It's a multi-billion-dollar market, supposedly, in smart devices, smart heaters, smart water boilers, et cetera, et cetera. What I think this means for devices is that the locus of intelligence is going to spread out across a lot of devices after having been in a kind of convenient era for about 10 years where the intelligence is all kind of in one device and we're beaming functionality out. But this has some implications. We did a really bad job with smartphones. I cannot stress this enough. Like every smartphone, these are being made by the hundreds of millions every year, and you can look up the statistics. I didn't want to depress you with them here, but it's really bad news. So I think when we get to the Internet of Things, connected devices, these things should be longer lived. They should have a longer plan, and they should be approached in a more sustainable way. Big companies don't really want to do this, which I'll talk about in a little bit. So we're trying to be the poster child of how else you might do it. I tend to think of this new age of devices as kind of little portable ships of Theseus. So if you know this idea from philosophy, if you have a ship and it is going to last a long time, you're going to slowly replace little bits and pieces of the ship over time. And after a while, you, in theory, will have replaced the entire ship. And at that point, is it the same ship or is it a different ship? That's a philosophical question. But we can approach hardware this way. There's a couple of really good projects out there that are starting to think this way. One is Project Ara, which, for better or worse, was acquired into Google a couple of years ago from a Kickstarter project called Phone Blocks. Project Ara's approach is essentially to build a frame which you can kind of click functionality, little hardware widgets in and out. If you're an electrical engineer, you will recognize immediately this is going to be really, really hard. They've done an outstanding job, but there are some significant electrical engineering challenges still to go for them. But how else might we do this same thing? How else could we approach it? I tend to focus on this idea of repairability, and that informs the manufacturing process as well. So our device is essentially an all-in-one, but it's completely disassemblable. Everything is snapped in or screwed in. Nothing is glued. Nothing is soldered. And just that simple shift enables this device to live 10 or 20 times longer than the average smartphone. If you lose one component, you can actually replace just that component. It's not a modular system, but it is a repairable system. So mass manufacturing devices this way is a lot more labor intensive and a lot more expensive, at least for now. So when we go to manufacturers and we say, hey, we have this idea, it has 17 screws in it, most manufacturers just go, so the first thing we'll do is replace the screws. And I have to go through the whole, oftentimes a translating process to say, no, we want to keep the screws. But I also don't want to condemn some poor team of people, I don't mean economically poor, but I mean unfortunate, to screw in hundreds of millions of screws. So my hope is we're, again, on another kind of crest, which is automated assembly. This is often talked about in what a bummer it's going to be to lose jobs, and that's part of it. But I think other jobs are thrown off if the really horrible parts get automated. There are still jobs. My hope is we can train robots to put in the screws and then let humans take them out later. And a lot of this is a phrase or paraphrases that's kind of thrown out a lot, but I wanted to talk specifically what it means to us and in our manufacturing process. I was talking to somebody last night at a dinner about why is it that you can buy a 30-year-old toaster or a new toaster, but kind of nothing in between. The 30-year-old toaster still works great, and oftentimes is the best toaster. The new toaster will work pretty well for a couple of years, and then something happens. You have to buy a new toaster. It's interesting. So our mission is to put that on its head and work with a concept called planned non-obsolescence. That is, to start at the beginning to make repair and hackability possible. And so just on a personal level, this is what it means to me in building this hardware. This device is rooted by default. It runs a variant of the Android kernel, and you can drop in there, be root, and do whatever the hell you want with the software. It is your device, after all, and you should be able to do that. 99% of commercial phones are not really yours from a software perspective. You can't actually do whatever you want. Companies tend to say, well, it's more secure this way, which I agree with, and we've had 20 years of the Linux community to show how we might get around those security problems and still provide root access so that you could, if you wanted to, do something different. Anyway, so that's a big part. And repairable, upgradable, that's critical. The other thing gets farther into the supply chain, which is, depending on how globalized your assembly process is, becomes harder and harder to see. We're sort of overly reliant on taking manufacturers' word for where their parts come from. But there's some tools coming online now as more ecologically minded people have recognized this problem. My favorite one is called Supply Shift, which basically lets you look at vendors. Okay, here's 8 people that I could buy a Wi-Fi chip from and put it in my device. 2 of these people have excellent sort of clean energy sustainability records. 2 of them say they do, but their numbers don't support. They're probably lying, and the other 4 are just not even trying. So if it's all the same to you, and oftentimes it is, these kind of tools let us pick good partners and that helps you be more transparent. Things still happen, but it's the other, like what's happening in the industry now is nothing. They're just buying the cheap one. The other big thing is this idea of reclamation. So when your cell phone dies, you can sometimes take it to a recycling place. We have in the United States this company called Best Buy with this horrible blue logo, and they have a smartphone recycling center, which is this thing you kind of drop your smartphone in and hope for the best. There's pretty good evidence that god-awful things happen to those devices once they go in there. So what we want to do is actually reclaim and recycle at a single point. Runcible comes with a box. If you don't want it anymore, send it back to us. We'll disassemble it, we'll reuse the parts, and even if we do tear it down, we will do the right thing with the component parts to the greatest extent that industrial culture lets us do it. There's blind spots no matter what you do. And then the last really important bit is this idea of open source everything. A lot of people don't realize that hardware is almost never open source. So even if you put your project together on a Raspberry Pi and it works and you actually get excited and think about making a product out of it, you can't. The Raspberry Pi schematic is not open. You can't go put that thing as made into production. You have to start from scratch again, use that sort of as a template, and design mechanical and electrical engineering from scratch, which is expensive and oftentimes inscrutable process. So what I've been doing is going to all of our vendors, in particular the silicon makers, and trying to explain to them this idea that we want to make the schematic for this device open. And there's head scratching and sort of silence, but we're making progress on all fronts there. The biggest hurdle, I think, is with the CPU, with the core ARM chip. There's almost nobody making a brain that we can use that is completely open source, open spec. But if I'm lucky, that'll change pretty soon. And the other interesting thing is in manufacturing, people who maintain large bodies of open source software don't always carry that through into the manufacturing process. So some companies are running around to large manufacturers and saying, hey, you're not allowed, please sign this contract that says, I will not manufacture anything based on this open source project that conflicts with the non-open source project. You can probably do the math and figure out who I mean. But it's fascinating to kind of get to the bottom of this type of stuff. But maintaining transparency is really, like, we want this device to be able to outlast us. And the only way we can do that is to make sure that it's all documented and all open. I was talking to Wired Magazine last month or so, and the guy was like, oh, this is cool. I think I get it. I'm into it. But what you're doing is way too hard. I mean, you're trying to change user behavior. And we talk to venture capitalists sometimes about that too, and they kind of flip to page 9, and they're like, startup wants to change user behavior, and there's a big X there, like, no, don't try to do that. They're smarter than that, but it is hard. So why the fuck are we doing this? This is one of my favorite quotes from John F. Kennedy, who was, I think, the last president that the US had. We might have had one in between. And he said, going to the moon is really hard. You're right. But we're doing it because it's hard. Doing difficult things is a way to know yourself, ultimately. And when you try very difficult things, at least in my experience with this product, we've seen a subset of our kind of extended digital community stand up and come toward us, which is really fascinating. It's not the same as kind of a high five at the tech conference, but it's really this, like, people are either like, I don't know what the fuck you're doing, or they literally stand up and they're like, I want to be part of this, I'm coming at you. And it's great. I think that sustainability, fundamental, is is this generation's moon. This is what we as a generation need to do. We got to fix the power problem, and we got to fix the electronics problem. There's lots of other problems, but this is my daughter. Her middle name is Moon, so this is my moon. But part of the why for me is to just exemplify another way that you could approach this stuff that will not screw the next generation and will give them a world that they can be part of and be innovative in. So that's me. Thanks very much.
I think we've got time for one quick question. Does anybody have any questions? Okay, I have a question then. My question is, what do you think, or so far from what you've seen with Runcible, what's the most useful purpose you've kind of, seen out there for people doing it?
So far, my favorite thing is sort of data channeling. Most of the stuff when I get free time to work on is reductions of things in my social world into something that's glanceable, which essentially, like, I can go and check Facebook and check Twitter and check Instagram, or I can make a kind of a summary of the behavior of all those networks and just kind of glance at it and know whether or not I need to deal with it. The other thing that I really just like as a pocket device is I have a lot of time back, and I find that my eyes are up more often, and my head is in the world more often.
Sweet. That seems to make sense for me. Okay, thank you very much, Aubrey, and we've got one more talk left, I think.
I think it's about the end. Yeah.
Yep. Thank you.
Thank you.